Right, welcome to a revision session for analysis of movement. Okay, we're going to have a look at specifically, we're going to have a look at levers to start with. We'll have a look at mechanical advantage, and then we'll pause the video. We'll do a bit of a revision card that I would like for you guys to do, and then after that we're going to have a look at planes and axes. Okay, and then I'm going to give you guys a multiple choice quiz, and then straight after that you're going to have an assessment. Okay, so just to remind you, there's a lot of memory tools involved in sort of the movement analysis. Okay, so just to go over 1, 2, 3 FRE. Now this helps you to remember how to draw the diagram for the different class levers. Okay, so the class levers, you've got class 1, class 2 and class 3 lever systems. Alright, so class 1, how to figure out how to draw the diagram. We all know we've got that line, and then it's a matter of where we put the fulcrum, where we put the effort, and where we put the resistance. Okay, that's very, very important. So it can, by being able to use this, you can get easy marks in an exam. Okay, so nice and quickly, a class lever system 1, a class 1. The first one here, so the F is in the middle. Okay, so that whatever's the FRE, this is let's put down here in the middle. Okay, in the middle of the diagram. So first up we have the fulcrum. So class 1, the fulcrum is in the middle. Bang. Okay. So let's do this as we go. Class 2, okay, the resistance, so the next one along, resistance is in the middle. Okay, so we have the resistance will be using that symbol, just a square. Alright, and then class 3, we just do a different colour again. Alright, we have the effort is in the middle. Okay, so we'll put here, we'll put a little line there saying effort. So we've got resistance, effort. The fulcrum you don't really have to label. Okay, it's just that symbol. Alright, and then how it works is it doesn't really matter where you put the rest of it. So remember, you've just got 3 symbols to put in. So you've got the fulcrum, and then here, a class 1, this could be the resistance on this side, and then if that's going down, to even it out, the effort is here. So the resistance and effort. Nice and easy. Again here, you'd have the fulcrum on this side then, and the effort on this side. Okay? And then here you have let's say the fulcrum will be on this side, and the resistance will be on this side. Okay, so that's all you have to remember, is just which one is in the middle. If you get which one is in the middle, then it doesn't matter which side you put the other ones. Okay, examples. Now this one's important. So that's having the knowledge of the being able to draw the diagrams of the lever systems. And this here is being able to apply it. So we've had a look at in past lessons examples for each of the classes of lever system. Now this is class 1. The example here would be the extension of the arm. Okay, so generally we're looking at sort of above the head. So for throwing in football, the throwing in rugby, it could even be the extension of the arm when you do like a tennis serve. Okay, all of those things. Sorry, I'm doing all the examples off the camera, but the example here would be any sort of elbow extension. Okay, so I'll give you a quick sort of example. If you were to throw a ball from your hand, that's your hand. Okay, that's your arm. There's your elbow. And the fulcrum would be, so the resistance, okay, the resistance is here, the fulcrum is here, in the middle of the joint, and the effort is here. Okay, so it's exactly the same as there. Resistance, fulcrum, effort. Okay, next example we've got, this is a class 2 lever system. Class 2 is going up onto your tiptoes, so it's plantar flexion. Alright? Plantar flexion. Right, so here you've got the balls of your feet, you've got your foot, your heel. Okay, so again, fulcrum is there. You've got the load is so the resistance is your body weight, center of gravity. So it'll be that coming down there. So that's your weight. All your weight's coming down through sort of the middle of your foot, and then eventually you'll have the effort is what is the contraction of the calf. Okay, so again, it's the same as here. You've got the fulcrum, resistance, and effort. Okay. You don't really have to. I wouldn't label F. Okay. So that's the example there for class 2. So going on to your tiptoes. That's all you have to remember. So any sporting action would be, say, sprinting. As you're just about to take off, you're pushing off the blocks. You'd show is plantar flexion. A diver, so as they're on the end of the diving board, they go up onto their tiptoes. So that's plantar flexion. A high jumper as they take off, or a long jumper as they take off. Okay, that's all that plantar flexion. Okay. And then finally we have a class 3 lever system, okay, where you have most other actions, okay, in the body, most other actions. So these are quite rare. The rest of the actions in the body are at the elbow and the knee, and generally they're third class lever systems. So third class lever system example would be elbow flexion. Elbow flexion, okay. Quick example, you've got the weight there, bicep there, and a forearm there. Okay. Now, how it works here is that you've got the fulcrum is here, you've got the resistance is here, okay, and then you've got the effort is there. Okay. Again, effort's in the middle. Fulcrum's to the left, okay, and the resistance is on the other side. Well, I mean the fulcrum, that could be the other way around, it doesn't matter. Okay, so third class lever system is the most common in the body, and an example is elbow flexion. Okay, it could be knee flexion as well. Okay, elbow and knee flexion. So it could be the bringing back of the knee during the sprint. So as you sort of recover the leg during the sprint. Okay, right, now we're going to sort of have a look at this side now. That's having a look at sort of just the 3 class of lever system, and this side is looking at mechanical advantage. Now the mechanical advantage, I think a lot of people got a bit confused on, but I'm going to try and sort of make it simpler. I'm going to try and sort of simplify it. All you have to remember is, okay, there's 2 mechanical advantages. One is for strength and one is for speed. Okay? Okay, so one is for strength and one is for speed. Alright, so this one up here, if you have a look, it's about knowing that there's these 2 terms you have to remember. Effort arm and resistance arm. It's really simple. Either side of the fulcrum, this length there is the resistance arm. This length there is the effort arm. So if we just do EA and RA. Okay, so as you can see here, the effort arm is a lot longer than the resistance arm. Now if you have the effort arm a lot longer than the resistance arm, okay, then you're going to have a mechanical advantage for strength. So here, for example, the simplest way of looking at this is if, for example, you had you were trying to lift a heavy load and you couldn't pick it up with your hands, best way to do it is you get a bit of fulcrum, so you get a rock here, big stick or a bar. You wedge it underneath that thing you're trying to lift, and you make sure this bit is as long as possible. You push down on it and you'll be able to lift it. The reason for that is because it's got a mechanical advantage. That lever is nice and long, the effort arm is nice and long. So you get an advantage of strength. Okay? Now here, you've got the opposite as it has happened. So this arm here is the resistance arm, and this arm here is the effort arm. Now, the resistance arm's a lot longer now. So if you, the example for this was when we had a look at the block, the experiment with the block and how high it flew up. Okay, it flew up a lot higher when the resistance arm was longer. Okay, the reason for that is because if you apply the same effort there, you're going to get this moving a lot faster. Okay, now you don't have to go into detail about it. You don't have to know the ins and outs of it. All you have to know is that if the resistance arm is longer, okay, which is the case in most of our joints. For example, this perfect example here. If you look at this here, that is the effort arm, which is tiny. But if you have a look at that, that's the resistance arm. It's a lot longer. Okay, so yeah, hopefully you can see that. So resistance arm, if it's longer, you get speed. Okay, mechanical advantage here, you get strength, and here you get speed. So MA, mechanical advantage equals mechanical advantage equals. Okay, hope that helps. Now pause the video. Okay, and I want you to actually draw this as a revision card. So you're going to copy that onto 1A4, and that covers the whole topic. It covers the whole topic of levers, okay, and mechanical advantage. Okay, so you should have actually got that revision card written down for levers. Now what we're going to do is we're going to have a look at the planes and axes. Alright? So, there we go. Again, another memory tool. We're going to start with this one. So, should remember, but it is Sophie takes Fleur shopping to London. Okay? Now somebody changed it and said, I think it was Simon. Simon takes Fred shopping to London. You can do it girls or boys, it's up to you. As long as you remember this, okay? The reason why I've got you to remember this is because generally what happens is these pair up. Okay, this will make sense in a bit, don't worry. These pair up, so these two generally go together, these two generally go together, and these two generally go together, okay? So I'm going to reverse a little bit now, okay? The first thing you need to understand is definitions. Okay, so what is the definition of S, which stands for sagittal? Okay, that is a sagittal plane. Okay, so it's very small. That is now this one is an axis. So I've put these symbols here. So that first one is a plane. This is an axis. Okay, so that's an axis, that's a plane. That's a plane, that's an axis, that's a plane, that's an axis. So it goes Sophie stands for sagittal, T stands for transverse. So the sagittal plane, you normally have movements happening on the transverse axis. I'll go into that afterwards. The next one, F, stands for frontal, okay? Frontal plane, that's a plane. And then normally in the frontal plane you can see movements occurring on the sagittal axis. So you get a sagittal axis and a sagittal plane, but that's the only ones you have the same of. You don't have